Yes, Ibrahim, Jasleen, am I audible to both of you?
Yes, ma'am.
Yes,
Oh,
ma'am.
all right. So, see class, we were at this derivation of potential due to a dipole at a general point. So, what all we discussed, let us just see that. See, here we just discussed that two charges were there, plus q and minus q, and they both were separated. This was like plus q was there, minus q was there, and a point, random point P was taken, which was making angle theta. When this side was drawn, this R1, this length was greater than this small r. So what did we do? We extended it and made it at a point where they could be equal. And for that purpose, we dropped the perpendicular. Similarly, it was observed that the smaller side, this R2 side is smaller than this R. So there was a point chosen where this could be equal. R and R2 can be equal. Again, a perpendicular drop was dropped at this point. So this was done till here. Then this from this triangle and this triangle, we just extracted two things. Net potential at point P due to a general point was KQ by R1 and one was minus KQ by R1. So when you take the net potential, it was KQ by R1 minus KQ by R2. Now class, what did we do in this smaller triangle, this triangle that was available, this one, smaller one, AOC. What did we do? We have just taken a point AC that is perpendicular and we have got our cos theta. Since this is theta, this will also be theta. So cos theta will be, look, this is the perpendicular drop. This is the base part to it. Here if you see, this is the base part that is present. This is the base, this is the hypotenuse, right? And this is the perpendicular. So when you have the perpendicular, look here, this side, this is the perpendicular, this is the base. So what can we say? We can say that cos theta will be what? Base by hypotenuse, right? OC by A. So from here we got the value of OC as A cos theta. Similarly, for this, so what did we do? We know that PA and PC, these two bigger lines that we have taken, they are equal. That's why we have drawn also. We have constructed them also. So we could write PO plus OC is giving us PC. And PC can be replaced with PA. So we can say PA is equal to PO plus OC. So R1 is equal to R plus A sine theta, A cos theta. This was done from the first triangle. Then from the shorter one, we did it till here that R2, this PB and PD, they are now equal. So PO can be written as PD, this PO can be written as PD plus OD. So from here, OD, we have taken out from this theta, again from this triangle, that is A cos theta. Remember, this is cos theta. So this is the base OD divided by hypotenuse A. So we got cos theta as A cos theta till the last class. Now, we wrote PD and PB are almost equal. So your PB can be written as PO minus OD. It means R2 can be written as R PO minus OD. So A cos theta. So till here, till this point, we did the construction part, right? Till here we have already completed. So this was R1 was R plus A cos theta and R2 minus A cos theta. Till here we wrote it. Right? Till here, is it clear to both of you?
Yes, ma'am.
Okay.
Yes, ma'am. Yes.
When we are writing the potential KQ by R1, so we can write KQ by R1 is R plus A cos theta minus second one is KQ by R minus A cos theta. That was the problem. That was the problem with our calculation. We didn't have anything which was related to R. Rather, we had R1 and R2. And R1 and R2 were just the numbers that were taken by us. Sorry, not the numbers, the variables that were just taken by us. So R2 and R1 couldn't come in our answer. That had to be replaced. So we replaced it properly with the help of R and A and cos theta, because theta, A and R are a part of our question. So let's take KQ common here. So we'll be left with 1 by R plus A cos theta minus 1 by R minus A cos theta. Now, when you have this, let's take the LCM. So V will be KQ is there. See, this term will get multiplied here. R minus A cos theta minus. Now, this term will be multiplied, but because of the negative sign, the sign will change. Minus R minus A cos theta divided by A into B. R plus A cos theta into R minus A cos theta. That's how we take the LCM. So, R plus A cos theta into R minus A cos theta. So R got cancelled. So V is equal to KQ. This becomes minus 2A cos theta divided by. See, this is like A plus B into A minus B. What's the identity? A plus B into A minus B.
From A square minus B square.
A square minus B square. So this will be A square minus B square. So that is A square minus B square will be A square cos square theta. Now look from here, 2A, if you just focus on this, 2A and Q, this is, they both are giving you P. So this can be written as minus sign is, you can exclude this minus sign, this negative sign which is coming, you can leave it. Because class, for negative charges, you'll already use it. And for positive, you will use it. So you just take the modulus because it's a scalar quantity. So when you take the modulus of it, you will get K, Q, this is K, no, not Q, sorry, KP cos theta. So K, P cos theta divided by R square minus A square cos square theta. So this is the dipole for the general point. Now for ideal dipole approximation, we know that when the length of the dipole becomes very lesser, length of the dipole become very less and R becomes greater. Because then the distance from the center to the dipole, it becomes greater wherever you are calculating from the center of the dipole to the point of calculation. So here you can use R square minus A square cos square theta approximately equal to R square. So the formula will become V is equal to, this will make it V is equal to Kp cos theta by R square. So this is the potential due to a dipole on a general point. General point means for any angle you can calculate. See class, electric field due to the dipole at any angle is just for your NEET, which we discussed also, under root 1 plus 3 cos square theta 1. That is just for the NEET part. But the potential due to any angle, due to the dipole at any angle, is for your both NEET as well as your board exams of CBSE. So don't get confused. That part which we discussed, that was exclusively for the NEET one. This is Kp cos theta by R square. Okay. So see here class, if we have Kp cos theta by R square. Now for axial line, look, if I just take a point like this, and here I am calculating, let's say this is my point A. So this will be axial line between the dipole and this point A. The value of angle will be 0 degree. So see, V is equal to Kp cos 0 degree by R square. Class, what is cos 0?
Mom 1.
1. Yes. So formula is Kp by R square. This is due to the axial. But see, on the other case, when you have the equatorial line, point is somewhere here. So this angle becomes 90 degree. Theta is 90 degree for you. V will be Kp cos 90 degree divided by R square. What is cos 90 degree, Jesleen? Yeah, Jesleen? What's
Sorry,
cos
ma'am.
90? Cos 90,
0.
0. Cos 90 is 0. So potential will be 0 at the equatorial point of the dipole. Okay, so this is the entire derivation. You didn't write, you didn't even write it till here. Or did you write this thing?
And we did.
You did?
Yeah.
Okay. So just continue it from here. Okay.
Ma'am, can you scroll?
Done?
Yes, ma'am.
Okay. See, let's practice a question. This says two charges are given. This is just the question. Graph part, you have to draw it by yourself. Two charges are there, plus q and minus q. They are placed at 0, 0, minus a and 0, 0, plus a, respectively. So whenever you have the graph parts, you have to read the coordinates. Coordinates means from the origin to the point of calculation. Basically, you always take it from the origin. And negative and positive will tell you the axis. whenever you have to read the coordinates, first question kya hai? Potential at point A, 0, 0, z. First, let us locate the charges. When it is saying 0, 0, minus A, this means this is your X, this is your Y, this is your Z. X-axis, Y-axis and Z-axis, right? Now, what is this telling you? That this is present at the Z-axis. So this means from where? What is minus A? One thing you know is it is on the Z-axis according to the divisions X, Y, Z. Next is this is A units from the origin, right? Now, if it is minus A means towards the negative axis, if it is plus A means towards the positive axis. Then is your A, which is 0, 0, z. Okay. Now, when we're talking about A, look here. This is your 1 point, which is plus Q is on minus A. No? So, plus Q, this is plus Q. And this is minus Q. Now, locating the point A, comma 0, 0, z means somewhere here. No, positive z is here. So 0, 0, z means towards the z axis and z unit from the origin towards the positive side. So here, somewhere here, you will have the point A, which is 0, 0, z. Now, for the first part, when you are calculating the potential, see class, is it axial or equatorial? First point. When we are calculating, is it axial or equatorial? Axial line or equatorial line? A point for the dipole. Dipole to ban raha hai. Plus Q and minus Q are there. Separated by 2A. So is the point A on the axial line of it or on the equatorial line of it?
Axial.
Axial. So formula is V is Kp by R square. Here your R is Z. So V will be Kp by Z square. Now second part, let's come to the second part. This says that potential at a point B, which is X, Y, 0, means X coordinate is there, Y coordinate is there, but no Z coordinate. So somewhere in the XY plane, let's say somewhere here, this is your B point, which is having some value from the X axis, some value from the Y axis, X, Y, 0. So class, how is this point? What should be the answer for B point? XY plane and Z axis. Think it like this. XY plane, let's say this is the XY plane. Okay, this is your XY plane. And Z axis is like this, right? This is the Z axis. So your XY plane and Z axis, they are perpendicular. So if I have a point B over here, here I have a point B. And here is my Z axis. So Z axis will be perpendicular to it, right? So it means this is the equatorial point. So for the second part, VB will be 0 because it is equatorial to it. That is theta is 90 degrees. Now look at this. C, X, 0, 0. It means only X axis is there and Y and Z are 0. So this is somewhere like this. Let's say this is somewhere here. This is your C point. X, 0, 0 means only X coordinate is there and Y coordinate and Z coordinates are 0. So X axis and Z axis, are they perpendicular? X axis and Z axis.
Yes, ma'am.
Yes, they are perpendicular. Exactly. So this will also make it equatorial. So VC will be 0. That is, again, this will be equatorial. That is theta is 90 degrees. Now see, like here we are just seeing varieties. How can you identify? See, if it's a normal question, on the axis, making angle theta, or equatorial axis is mentioned, that you all will be able to do. Problem arises when you have the coordinates. So these are the maximum possible questions that can come, all kinds of coordinates we are seeing. Now class, work done in carrying a proton from B to C. When you have the potential is as 0, then change in the potential will also be 0. And when you are carrying this proton from point B to point C, that time also the work done is charge multiplied to to V. So Q into 0 is 0. So there won't be any work done since there is no potential existing. And your work done always comes in your system when you have a potential. So no potential is there, you're simply straight away you have the work done as 0. So for the third part, see, VB is 0, VC is 0, VC minus VB will be 0, which is delta V. So work done is E into delta V. Why E? Because proton is given. And if there was a value of delta V, we would have written it like this. So E into delta V like this. So this is 0, work done is 0 in this case. Does work done depend on the potential between B and C? There is no potential. How will it exist? How will it depend? It actually depends on the potential. But right now there is no potential. So work done is C. So work done is actually dependent on potential since the potential difference is 0. The work done is also 0. Otherwise, potential depends. Then we are going to see a very important topic, but you write it till here. Is it clear, Jaslin Ibrahim?
Yes, ma'am.
Okay. Only Ibrahim has attended the paper. Jaslin, why didn't you attend? I wanted to discuss the paper. Will you
There
be
was
able
a problem
Yeah?
because when I had the time slot for the paper, they sent the wrong paper by mistake, and by the time they got the actual paper, the time slot was over, and I didn't get time after that.
So do you have the PDF with you? Can you share it with us on WhatsApp? Hmm?
Should I complete it this week or should I send it?
But you have the exam this week, I guess. You know? Jaslin, you must be having some exam. Current, electricity, atoms, nuclear. When is that exam?
Next Monday.
Monday.
Yes, ma'am.
19th.
Yes, ma'am.
Okay, so will you be able to attempt it because the syllabus is different?
I'll try to give it on Wednesday.
Okay, Wednesday if you can give, then fine. Then we have the class on Wednesday. Then I'll discuss the test paper on Wednesday itself. Okay, if you're attempting. Otherwise, see, Ibrahim's everything is on time completed, so he shouldn't lack the discussion part. No, the test papers discussion is necessary. So, Jaslene, it's very good if you can attempt it on Wednesday. Then we can have a final. What you can do is share your test paper on the WhatsApp only. If you are not able to, if you are unable to upload it anywhere, but just complete it before our class. So at least even if it is unchecked, just before the class, just complete it so that I can discuss. Because after the discussion, there is no point of attempting any test. Okay. Okay, Jaslene then. Please write it, all of you. Is it done, Jasleen and Ibrahim?
Yes, ma'am.
Okay. See, there's a relationship between electric field and potential, and this is a very important topic in your NCERT, and often the questions come from this. See, these are electric field lines, and how do we get the electric field from electric field lines? We drop a tangent, remember? We
Yes,
drop a tangent, that is theta. So, see, suppose this is the electric field, and we have moved a charge from A to B. We have moved the charge from A to B. Okay, so look, work done in carrying charge from A to B. First of all, when we are talking about the force is, if the electric field is E, charge is Q. So force will be Q into E. Now see, so let's say the separation between A and B. This is some dx. Let's say the displacement is some dx. So when we are calculating the work done, it will be force into dx. That is Q into E dot dx. Correct? This is the work done, one point of work done. Now class, we've already studied that when we move a charge from one point to another point against the electric field. So the work done is given by charge into change in potential, let's say dV. Now this is one equation, this is second equation, they both are leading towards the work done. So when you equate it, Q into E dx is equal to Q into dV. So charge gets cancelled. What is left? E is equal to dV over dx. Now class, what is E? E is the electric field dV over dx. See, what is dV over dx? dV over dx. This is called as the potential gradient. Potential gradient. Gradient means when something changes with position. Like remember in class 11th, we have done rate of change of speed is acceleration. Rate word was there, means something is changing with respect to time. Now you have gradient. Potential gradient means something is changing with respect to position. What is this something? Potential. So when the potential changes with position, it is called potential gradient. Now class, this is not complete information about this. There is a negative sign also present with this. But class, this derivation often comes in the exam. Very small derivation it is. And there are 2 points from the formula E is equal to dV over dx. dV is written for a very small charge. If you have a significant difference, you can write it as delta V by delta X also, right? So dV by dr is what? This is basically change in the potential with respect to the position. The formula is not this. We write this as minus dV by dr. A negative sign is also present in the formula. Also, why this negative sign is present, I'll tell you here. There's a significance of negative sign. 2 important points are extracted from this formula. How E is dV by dx or dV by dr. I hope that is clear to you. Where your dV is the, let me write it here, dV is the change in potential. Okay, and dx is the change in, you can say, displacement. Basically, this is the change in position. So change, this is, you can refer it as the displacement. So change in position. So if the change is significant, you can write this as delta V by delta R also. Or sometimes V by R also works in as a formula. So what was important from here? I'm coming back to this. Don't look at this one now. What's the significance of this negative sign? This negative sign basically tells you that the direction of electric field is where the potential decreases. Like if I give you 5 volt is there, 2 volt is present. Which is greater? 5 is greater obviously than 2 volt. So when I see the direction of electric field will be where the potential is lesser. So 5 to 2 volt, higher to lower. So 5 to 2 volt. This is the direction of the electric field from higher to a lower value. So this is the potential gradient dV by what all things you have to remember. Now I told you two important conclusions. One conclusion says that electric field is directly proportional to the potential gradient. This is one important conclusion. Second is regarding the sign. That direction of electric field is where the electric potential decreases. Now, when you write it, when you are differentiating it, sometimes differentiation is required like this when the value or the change is very, very less. Or if it is significant, you can subtract delta V by delta R. Or if it is directly potential is given and distance is given, you can write it as V by R. Now, if it is specifically for x-axis given, so electric field's x component will be minus dV by dx, means the change will be with respect to the x-axis. Or y will be minus dV by dy, that is change with respect to the y-axis. Or minus dV by dz means change with respect to the z-axis. So x-axis, y-axis, z-axis like this, specifically if axes are mentioned. Now there's a concept of partial differentiation. You write delta V by delta X, delta V by delta Y, delta V by delta Z. But this partial differentiation part, we'll do it separately in today's class only. This is not a simple differentiation, what you've studied it in your class 11. We'll do it again. So this I'll discuss it properly. Any doubts in here? Relationship between electric field and potential. Work done is QE into dx and see this is QE into dx and your potential work done is charge into potential. So when you equate QQ gets cancelled, E is dV by dx till here. This E is the electric field, dV is the potential, dx is the position. So dV over dx becomes the potential gradient. This is just a term, potential gradient. So tell me, in this part, is there any doubt? Is it clear to both of you?
Yes.
Yes, ma'am.
Okay. Then electric field, if the change is very slow, you can differentiate it dV over dx. If the change is significant, you can use delta V by delta R. If only position and potential are given to you, you can use V by R. For X, Y, and Z axis separately, you can differentiate it with respect to their own individual axis. What is important from here is the conclusion part. From this, is it clear, this part?
Yes, ma'am.
Yes.
Okay. And then you have two very important conclusions. One says, according to the derivation, electric field is directly proportional to dV by dx, that is the potential gradient. And second says there's a negative sign which doesn't come in our formula because it tells the relationship between electric field and the potential. So this says that direction of electric field is where the potential is least. It is decreasing, like 5 volt to 2 volt, higher to lesser. You also go higher to lesser. This partial differentiation we'll see later. First we'll do this question. But write it, quickly write it till here. Last part is also clear to both of you, this one?
Yes, ma'am.
All
Yes,
right.
ma'am.
Oh, great. Please start writing from here. This is very important class. Please write it. Class, have you written it till this part? Should I scroll?
Yes, ma'am.
Yes, ma'am.
Done?
No, ma'am.
Jesslyn, you've also written?
No, ma'am. 1 second.
Okay, okay, right.
Done, ma'am.
Okay, class. See, we have studied V is KQ by X. Then what is electric field? Look, if potential is KQ by X, that we already know, electric field is asked. So we know electric field is minus dV over dx. So it means we have to differentiate potential with respect to X. So minus dkq by X over dx. Look class, minus kq will come outside. And 1 by x, this x can be brought up in the numerator, x to the power minus 1. Right. Oh, we have to differentiate it. This can be written as dx to the power minus 1 over dx when you differentiate it. It's like this V's potentials equation can be written as k q x to the power minus 1. Right? So this is kq d to the dx to the power minus, this is x to the power minus 1's differential. Equation is kq x to the power minus 1. So kq has been taken out, x to the power minus 1 is left for differentiation. So look, minus kq is here, x to the power minus 1. So it will be, see, x to the power n becomes n x to the power n minus 1. Here n is minus 1. So minus 1 into n x to the power minus 1 means n minus 1. N x to the power n minus 1. So electric field will be, see, minus into minus will become plus kq x to the power minus 2. We'll shift x in the denominator, kq by x square. So are we correct till here? Is it the formula of electric field due to a point charge or not?
Yes, ma'am.
Yeah?
Yes, ma'am. Yes.
Yes. Right. Write down this one quickly so that we can practice one more question. Done.
Yes.
Jasleen?
Yes, ma'am.
Okay. See, it is saying if V is 3x cube, what is the electric field at? X is equal to 2 meters. See, potential for electric field, we know it is minus dV over dx. And what's the potential given? Potential is given as 3x cube. So when you differentiate electric field as minus d3x cube over dx. So 3 is a constant. Let's differentiate it. 3 is a constant. So electric field will be minus 3 will be taken out. X cubes differential. What will it be? X cubes differential. Hmm?
From 3x square. No, yeah.
3x
Yeah,
square.
3x.
Yeah, right. 3x square. Correct. So this will be 3x square. So electric field's equation is minus 9x square. Now at x is equal to 2 meter, we'll just have to put it. Electric field will be minus 9 into 2 square, which is electric field is minus 36 volt per meter. Now you can use the unit volt per meter also. One is Newton per coulomb because of F is equal to QE. So E is F by Q. And second is this. Okay. Write down this one quickly. So whatever equation they give you, I hope you will be able to differentiate it. Just differentiate it, whatever value they say, just put it. Like you used to solve the questions of velocity and acceleration in class 11. Similarly, like that. Done.
Yes, ma'am.
Jesslyn?
Done, ma'am.
Done.
Yes, ma'am.
Okay. See one more very small, easy question. Potential difference between A and B is given as 20 volts. So see, this I am telling you, like when you are given to differentiate it, you can differentiate. But if you just have position and potential, then simply divide it. Don't think what's the initial value, what's the final value, because already you have the difference, potential difference. So this is also the difference between point A and B. So in such a case, see, E is minus V by R. Use it like this. So minus 20 by 10. So electric field is minus 2 volt per meter. Okay, quickly write this one also. Now from potential, only potential energy part is left. That will be completed on Wednesday. We were supposed to have 2 hours class, but some of the students have their exams. So today it is of 1.5 hours, but I think from the next class it will be for 2 hours. This chapter will be completed by the next week. Okay, capacitance will be left. Okay, see, partial differentiation, let me tell you, partial derivatives, how you have to solve it. See, for partial derivatives, you don't differentiate it the way we have studied differentiation. What you do, let's say there's an example, V is x square, y z square. So electric field along the x-axis. See, in partial differentiation, basically we are taking the components out of it. Ex, Ey, Ez. We are taking the components out of it. So electric field on the x-axis will be given by minus delta V over delta x. Okay, minus delta V over delta x. Now, when you are differentiating it with respect to the x-axis, your y and z will be constants. Okay? Y and z will act as constant. Don't think that this is a variable term. Just think as if it was a constant, like 3 was given, 4 was given. So what we do? We take the constant out. So this will be y z square as it is. Just like 3, 4, we bring out the constant value. X square is left. X square will only be differentiated. So x square is differential. Jesleen, you tell me. Yeah, Jesleen, x square ka differentiation. X square will be 2x. Yes. So it will be 2x. So this is the answer. Now, when I'm differentiating Ey minus delta V by delta y, now I will take x and z as constants. Okay, x and z will be constants. So if x and z are constants, so x square and z square will come out. Only y is left. Dy over dy is what? 1 only. Differential of y is what? Dy over dy. That's 1 only. So this is it. And when we have it along z axis, this will be minus del v over del z. Now, x and y are constants here. So when x and y are constants here, so look, x and y are constants. So x square y will come out. Z square is left. That will become 2z with a negative sign. And now when you need to write the net electric field, you can write the net electric field as C minus y z square 2x I cap minus x square z square j cap minus x square y 2z k cap, like this. But if you are asked to calculate electric field at a point like this, electric field at 1 comma 1 comma 1, then put it in that equation only. Electric field will be, see, from the first one minus 2, right? This is 1 into 1 square. This is like 1 into 1 square into 2 into 1 I cap. minus 1 x square z square minus 1 square j cap. And this will be minus, this is 1 square 1 into 2 into 1. So overall this will become minus 2 cap minus j cap minus 2 k cap. If you are required to calculate the magnitude, you can calculate the magnitude as how? How to calculate the magnitude of this vector electric field? This one. How will we calculate the magnitude of this? Minus 2 cap minus j cap minus 2 k cap. This is the equation.
Ma'am, root of minus 2 square plus minus 1 square plus
Very
minus
good.
2 square.
Very good. Exactly. The magnitude of electric field will be, if it is asked to you, minus 2 square plus minus 1 square plus minus 2 whole square. So when you take it out, this becomes 4 plus 1 plus 4. Okay. So this is 8 plus 1, 9. That is 3. So electric field's magnitude will become 3 volt per meter. Is partial differentiation clear? Was this tough? No? It was easy? You differentiate it normally. It's just that constant, which all terms are constant. See, if other constants are given, that will be treated as constants only. But if these x, y, z, all these things are mentioned, then these things you have to take them as constants. Okay. So this writing part, we'll do it in the next class only. That completes with this whole entire topic of potential due to a dipole is completed and electric field's relation with potential is completed. And that's a major topic from potential. Now we are left with potential energy. That is not a very big topic. It will be completed on Wednesday, and we'll start with capacitance itself on Wednesday. So we expect to complete the chapter by the next week, and so that we can start with current electricity. Okay, so it's the time is up. We'll meet next on Wednesday. Okay, and please try to submit the